So to demo the exercises that we prepared, here is the checkpoint for exercise 1, which is the code chunks I showed earlier, but combined into a singular script. And you can run the script in order to get this split panel app on the bottom that you can drag around, explore, and you can also modify the parameters inside the script to visualize a fire of your choosing. The second exercise is about the Firms app. So once you go to this link, you'll see a area of interest polygon drawn at the Central African Republic with these default temporal bounds here. So you can modify this to whatever you would like, and then also draw your own rectangle or polygon. And then if you wish to look at the Bobcat fire, you can pan the map to the Western US in Southern California, and then draw an area of interest polygon here, and then also set the time range, and just to make sure to include 2020 as well. And we've created a unique link which covers the parameters for the Bobcat fire. So here we've put in the day of year range and a time range covering 2020 that goes back to 2010. And then we've drawn a rectangle around the Bobcat fire. And once you run the script, it will have this time series plot of the active fire counts from Modus. So this shows a time series of the total fire counts within the area of interest. And you can see here for 2020, there was a huge spike in fire counts, which represents the Bobcat fire. And you'll also notice that you can create unique links according to your parameters. So you can easily share a specific time series with a collaborator or with a friend. So this is one way to save the state of your app as well. And the third exercise is about the Bobcat fire and the parameter derived from the ghost active fires. This app, just to note, is very slow, so you might have to run it a couple times and wait a couple minutes. This is because all of the parameters are computed on the fly using a lot of data. So here it's showing on the right the ghost active fire data, where the active fire data quality flags are converted into confidence. And the different polygons are representing parameters that's estimated using different confidence thresholds. And the charts here show the progression of the fire in terms of burn area, animation of the fire as it evolves through time and space, as well as the total active fire pixels that's contained within the area of interest. And I've also added land cover layers here, as well as the burn severity that's estimated from the post-fire and pre-fire images from Sentinel-2. So you can also see where the fire was most severe within the perimeter as well. And then the bonus app is called Gopher. So this is using a similar method to what's shown here, but having more optimizations and using saved assets. So it's a lot more faster because those layers are pre-computed. And then if you wanted to look at the Bobcat fire, for example, it will show all of the hourly parameters that's derived after ignition. So here, it's showing in colors the timing after ignition, where each individual line represents a parameter after ignition. So the bluer colors show after ignition, and then how the fire is evolving through time and space. So the redder colors here are showing much later after ignition and where the fire has progressed to. And we've also derived other metrics using this data. So we've also derived simply the area, the growth in area for every hour after ignition, as well as the active fire line and the fire spread rate. So you can read a little bit about this here, as well as in our preprint, and also in our GitHub repository, we have the code on how to derive these metrics. And if you drag the slider on the left here, you can also reveal another panel that shows a specific time slice. So if you click on a point here, it will show you what the fire looked like at that particular time, as well as the active fire line. So you can quickly zoom to a specific time and see what the fire was doing at that time. And then along with the fire data that's derived from ghosts, I've also added in other data sets like the land cover. So by clicking on these boxes here, you can reveal different layers. So there's land cover and then also burn severity from MTBS, which is a Landsat derived product at much higher resolution. So you can also see again here the burn severity for the Bobcat fire. So this is all I wanted to show, but I'm happy to answer any questions about either the coding, the active fire data sets, or the Earth Engine apps that I showed today.